So if a sample of an illegal drug is seized in a raid or is discovered being smuggled at an airport, and the investigators find, for instance, a white powder, how do they detect and identify the illegal drugs? Well, there's a number of chemical tests that can be done, and these are based on treating the unknown sample with chemical reagents and looking for particular color changes. For instance, the Marquis test gives a red-purple color from heroin, an orange-brown color from amphetamines, while the Scott test gives a blue color for cocaine. But as we know from the lecture on identifying particular compounds, we really have to turn to chromatographic and spectroscopic methods to really prove what these compounds are. For instance, we can use thin layer chromatography, which we talked about in the earlier lecture. But we know that thin layer chromatography is not very precise, and if it's used, can only ever be a presumptive test. What we need to do is to use more sophisticated instrumentation, the more sophisticated chromatographic methods that we talked about earlier, for instance, gas chromatography and HPLC. For identification of the compounds after the chromatographic separation, we would use the infrared, and particularly looking at the fingerprint region of the infrared spectrum. Then the other technique for identification we can use is mass spectrometry, and as you saw in that earlier lecture, we can combine mass spectrometry with gas chromatography and do GCMS. One of the ways that is used to detect and identify a drug in a body fluid such as urine is called immunoassay. And this involves generating antibodies to the drug and setting up the immunoassay in such a way that when the substrate, for instance, cocaine or amphetamines or morphine, binds to the antibodies, this chemically triggers a color change. And that color change can be very quickly and simply observed by the investigator. Well, these techniques, the immunoassay techniques, have come in for a certain amount of controversy, partly because of their very, very high sensitivity. Perhaps that sensitivity can be too high, and if not used properly, can give very misleading results. For instance, morphine. There are immunoassays available for the detection of morphine in urine. So the assumption would be if that someone tests positive using this method, then they must be a heroin user. But it's not necessarily so. Morphine is produced by the plant Papaver somniferum, and this is one of the poppy family. It turns out that almost all poppies produce morphine, but all the other types of poppy produce it in very tiny amounts. And poppy seeds, of course, are used to flavor, for instance, bakery products, such as a poppy seed bagel. So if somebody eats a poppy seed bagel, there will be trace amounts of morphine in their system. Not sufficient to have any effect, but if the immunoassay test is not done properly, it can be sufficient to give a positive result. So someone may be condemned as a drug user, whereas actually they just had a poppy seed bagel for breakfast. So if we sum up what we've learned in this lecture, there are three types of illegal drugs. Natural compounds, which are extracted directly from the organism that produces them, such as morphine, cocaine, and cannabis. There are semi-synthetic compounds which are obtained by chemical modification of those natural compounds. An example would be heroin. And then there are the purely synthetic compounds which are made by chemical means, and an example would be ketamine. All of these can be detected and determined using the techniques of spectroscopy and chromatography that we learned about in our earlier lecture.